In this video we are going to learn the base of all computer graphics, pixels and color. How do you represent a color? We know that when electricity flows through a bulb, it dissipates into heat and light. The amount of light is directly proportional to the current and the voltage. So we can increase or decrease the voltage to change the intensity of this light. Let's say that we have a range of voltages from 0 to 1. If the voltage is 0, the light is at its minimum intensity. When the voltage is 1, the light is at its maximum intensity. And any value in between is a blend between the two. Let's say that this is a white light. It is black at 0 voltage and white at a voltage of 1, so we can blend the colors black and white through this linear interpolation. Now let's take 3 lights. The first light should be red, the second should be green, and the third should be blue. These 3 lights combined can show any color that you can imagine. For example, if all 3 lights are completely lit, they make the white color if seen from far. If all of them are turned off, they make the black color. If only the blue light is turned on and all other are turned off, that makes the blue color. Similarly, if only red is on, that makes the red color. If red and blue are turned on, they make the purple color by blending. If the green and blue are turned on, they make the cyan color, and if red and green are turned on, they make the yellow color, and other values in between make other colors. This is a gradient that shows all of the colors blended between. Now let's say that these 3 lights combine to form a pixel. Let's take many pixels in a 2-dimensional grid. Each pixel has a position and represents a color. Each color represents 3 numbers, R, G and B, which are the values for red, green and blue lights. We can change the color of each light by changing the voltage supplied to that light. In this way we can form images of very low resolution. Note that the color of each light is represented using 3 variables, which means that light's color has 3-dimensional freedom. We can represent this single color in 3 dimensions with a single point at a specific coordinate, in which the R value corresponds to the X value, and the G value corresponds to the Y value, and the B value corresponds to the Z value. We can draw 3 lines representing the intensity of each color. If these lines meet at a common point and are perpendicular to each other, they form a 3-dimensional space. So every color in this world has a specific position in this space. Now that we have understood the basics of color, we can keep adding on pixels. Let's say that we make a grid of 16 by 16 pixels. Each pixel has a specific position and color. We can again change the color of each pixel to form any image we want. This 2-dimensional array has a height and width of 16 pixels, so it has total 256 pixels, which is a very low resolution, about 0.0003 megapixels. We can increase the size of this grid to 853 by 480 pixels, which is the standard 480 pixel image. it has 409,440 pixels, so its resolution is 0.41 megapixels. An array of 1280 by 720 pixels form the standard 720 pixel display, which has 921,600 pixels and its resolution is 0.92 megapixel, and so on. Here is the list of some standard resolutions. Until now, we have learnt how to represent images by changing the color of individual pixels, which is called raster graphics. In the next video, we will talk about how to draw basic shapes using raster graphics in a computer. You get it, just subscribe.